Okay, so here we go. Hopefully you tried some of these. See if you're right or wrong. We'll see how we do. So 2-chloropropane. My longest chain is 3 carbons, single bonds, A-N-E. 2-chloro tells me about the second one. I have a chlorine. It could be top or bottom. Doesn't matter. And don't forget the hydrogens are here. I'm just not drawing all of them. You should realize that they're there. A 1,2-dichlorobutane. Butane means there's 4 carbons. It's all single bonds. And then a 1-chloro, 1-chloro, 2-chloro. Tells you which one is. Now these chlorines could be on the top, on the side, or the top. Doesn't matter where they are. A 1,4-dichloropentane. That means I have 5, 2, 3, 4, 5. All single bonds because they're anes. And off the first one I have a chlorine, and off the fourth one I have a chlorine. Could be tops or bottoms or sides. It doesn't matter where they are. It doesn't tell you. Heptane means I have 6, 7. That means I have 7. And off the third one I have a methyl group. In other words, I have another carbon with hydrogens attached to it. So it's going to look something like that. And the methyl group could be on the top of this too. Doesn't matter. 2,2-dimethyl octane. Octane means I have 8, 4, 5, 6, 7, 8, big one. And then 2,2-dimethyl, that means I have a methyl group off this one and a methyl group on the other side. It means if I had 2 carbons consecutively, so I had one here and another carbon here, that would be an ethyl group. So realize there is a bit of a difference. Watch out for those. Hopefully those made a little sense. We can go over some more later. All right, so functional groups, let's see how we do with this stuff. When we're identifying, you gotta tell me the family, then you gotta name it. So you gotta go back to that alcohol, aldehyde, organic acid type of deal. So here, so I would definitely look at those notes if you guys got it. So here you gotta identify the family, and then you gotta identify what it is. So here I have in the middle of the molecule, I have a sandwich one, and then I have a double bond to an oxygen. That is family is an ester. Okay, and here's how you name it. You name that side first, the one without the double bond, so it's a propyl. Then name the side with prop, and then you add OAT. Propyl propanoate. All right, propyl propanoate. Next one, you can skip this one. We're not going to do ones with nitrogen in them. Family, oxygen with a double bond to an oxygen. This looks like what we like to call an organic acid. So all I got to do is add oic acid. My longest chain is 4. Butanoic acid. Sandwiched oxygen here. That's just pretty much easy. That's just an ether. Ether, all you gotta do is tell me what you have on each side and put ether at the end. So it's a methyl ether, or if you want to, because these names are the same, you could say dimethyl ether. Your call, doesn't matter to me. Here we have oxygen hanging off the main chain right here. Oxygen like this is a ketone. And make sure you gotta tell me where it's located on this one. So how many carbons do I got? I got 4, I got 5, so it's a pent. It's a pentanone. Tell me where it is. It's located on the third one, so it's a 3-pentanone. This one we just have an oxygen hanging off the end with the hydrogen. All right, that is going to be, that's going to be just a basic aldehyde, right? Yep, aldehyde. Aldehyde, remember aldehyde, AL ending. So I have propanol, AL ending. Next one, there's no side chains, nothing hanging off side, but we do have a double bond. This is an alkene, okay, or ENE, and you have 1, 2, 3, 4. So it's a butene, and the double bonds look at the first one, 1-butene. And the last one we got here, we got a OH hanging off the end. OH is some type of alcohol. So it's a butanol. And tell me the location. It's a 1-butanol. And this side of the deal, you're just going to go through and tell me the family and draw it. So kind of the opposite of what we just did. So 2-pentanone, the family is a ketone. Pent means 5, 1, 2, 3, 4, 5. And it's off the second one, I have my double bond. Could be top or bottom, doesn't matter to me. Second one, propanoic acid. Oic acid is organic acid. Okay, prop means 3, and then I have either end, doesn't matter what end, it could be this end or it could be that end, either one. All right, these are those nitrogen ones which we're not going to talk about, that's why we block them out. Methyl ethanoate, this is what we like to call an ester. Okay, ester, so that means we have methyl on one side, so that means we have a carbon with my sandwiched oxygen. And then we have another carbon with a double bond. How many do we have? 2. Looks something like that. There's my eth, here's my meth. Methyl propyl ether, well it's an ether, the name's in there. And all you gotta do is draw each side. One we have 1 carbon, the other one we have 3 carbons. It's gonna look something like that. OL means it's some type of alcohol. Same with the bottom one. Also some type of alcohol. You just gotta draw them. So we have 1, 2, 3, 4, 5. OH could be on top or bottom, doesn't matter. 1, 2, 3, 4, 5. This is not the first one. Let's just put the first one right here. Because remember, you can be left to right or right to left. Isomers. Hopefully we went through a bunch of those on your notes and you looked at those. So which of the following molecules is an isomer of propanol? In other words, same formula, different arrangement. All right, same formula, different arrangement. So propanol has C3H and then OH at the end. So it's going to be C3H7OH, or you could write it C3H8O. Depends how you want to do it. Either way, it'll all work. And really, what this one's going to be, so the 3 carbons. So here's 3 carbons pro. Here's 3 carbons total. 1 plus 2. Here's an Al, which means it means an aldehyde. Here's an organic acid. So this organic acid probably is not going to work because that means it's going to have 2 oxygens in it. The propanol, Al, this is probably not going to work because it has a double bond to an oxygen, which takes away a hydrogen. So one of these 2 is going to work. The question is which one. And my guess is that it's probably not going to be this one because this is a double bond to an oxygen, which takes away a hydrogen. So if you drew this, see, and I went 1, 2, 3, 4, 5, 6, 7, like that. So the only one that's going to keep the same amount of hydrogens but yet double bond to an oxygen is going to be an ether. All right, so same numbers. If you notice, ethers and alcohols are actually pretty synonymous to each other. Or in other words, there are usually isomers. So with that being said, draw the structure of the alcohol that has the isomer of ethyl propanoate. So 2 carbons, 3 carbons, 5 total carbons. 1, 2, 3, 4, 5. And you just gotta say I need OH. Boom, done. All right. So alcohols and ethers are usually going to be isomers to each other. And which of the following alcohols has the largest number of possible isomers? The more carbons you have, the more isomers you get. 1 carbon, 2 carbons, 3 carbons, 4 carbons. This one's going to have the highest because the highest number of carbons in there. All right, so there's your notes. Hopefully you got some right. Make sure you ask questions if you need more stuff.